Hello everyone and welcome to the lesson on solving multi-step linear inequalities with one variable. Our objective for this lesson is to be able to solve multi-step linear inequalities. And before we get started with practice, we just want to take note of one important rule when we're solving linear inequalities. Okay, so this rule is if we multiply or divide both sides of the inequality by a negative quantity, then the inequality symbol okay, the inequality symbol reverses. Okay, it reverses. It flips, it changes directions. And we will see exactly what we mean by this as we work through these examples. But we just want to take note of this rule because it's very important. So we're going to put a big star by it because we can't forget this rule. And the key things are is if we multiply or divide, okay, by a negative quantity, then the inequality symbol reverses, okay? So if we have a negative quantity that we multiply or divide by, our inequality symbol is going to flip. And we'll see what we mean as we go to practice. So let's just take a look at our first example. All right, and we'll keep that rule in mind. We'll just keep it right there towards the top and refer back to it when we need to. Okay, so our rule will stay there. So let's look at our first inequality. We have negative 6 times 1 plus 5x is greater than negative 96. So here, my inequality symbol is here, and my variable is x. Now, my goal is to solve for x, and I'm just keeping my original rule in mind. So what I'm going to do to solve for x is the same procedures that I would follow in order to solve just a regular equation. All right, I'm going to simplify my left side before I consider switching anything across my symbol. So to do that, I'm going to use my distributive property and multiply both terms by negative 6. So 1 times negative 6 is negative 6. Then negative 6 times 5x is going to give me negative 30x. Okay. So the left side simplifies to negative 6 minus 30x, and that is greater than negative 96. Okay. Now I still want to solve for x, so in order to undo this negative 6 on the right, I'm going to add 6 to both sides. Okay. So negative 6 plus 6, they cancel, and I'm left with negative 30x, which is going to be greater than negative 96 plus 6 is going to put me at negative 90. Okay. Now, my last step, I see that x is being multiplied by negative 30. Okay, so in order to undo multiplication by negative 30 to get the x by itself, I'm going to divide both sides by negative 30. And divide here by negative 30. Okay, now I've divided by a negative. So again, I go back to my rule at the top and it says if we multiply or divide both sides of the inequality by a negative quantity, then the inequality symbol reverses. That's very important. So just take note of what happens here as we finish this problem here. So we've divided by a negative 30. So the negative 30s cancel on this side, and what I'm left with is x is greater than, or sorry, my inequality symbol switches, flips, all right? So it changes from being this way, and then I multiply by a negative here, and then it changes directions, it flips, okay? So now x is going to be less than, I have a negative divided by a negative, and I know 90 divided by 30, or 30 goes into 90 three times. Okay, so x is less than 3 is my solution set. Okay, now if I had a number line, okay, I would find the point 3. So let's say here's my 0. 3 would be 1, 2, 3 spaces to the right of 0. And this is a strict inequality, so remember that my circle will be open. And then I want all values of x less than this number 3. So I'm going to shade to the left. And that would be how I would graph my solution set. So here is the algebraic solution. Here is the graph of the solution set. Let's consider our next example. We have here 6z plus 6z is less than 12. All right. So again, before I consider moving across my symbol here, I'm going to make sure both sides are already simplified. Now, 12 is simplified. That's just 12. I can't do anything with that. But on the left side, I have 6z plus 6z. And I know that these are like terms, so I can combine them. So 6z plus 6z is going to give me 12z. Okay, that's just combining like terms on the left side. And this is going to be less than 12. Okay, now I'm going to divide both sides by 12. Now 12 is a positive number. So notice that my inequality will just stay the way it is. And on the left, I'll be left with just a z. And then on the right, 12 divided by 12 leaves me with 1. So that's my solution, okay? And this was a multi-step inequality because we had to simplify the left side before we performed our division on both sides. We divided by a positive, so there's our inequality symbol remains in the same direction. And x is less than 1 is our solution set. So again, if we have our number line and we have 0 in the middle, 1 will draw 1 unit away from 0. Okay, and then if I start at 1 and my circle is going to be open because there is no equality portion to this, it does not include the value 1, but I want all values of z that are going to be less than that. So that's going to be all values going to the left. Okay, so here's my algebraic solution set. Here's my graphical interpretation of the solution set. And let's look at our last and final example for this lesson. And we have here 155 is greater than or equal to negative 5 times 1 minus 8x. So I look at this again, my left side is simplified. I notice on my right side that I can use my distributive property to simplify. So I'm going to do that. Okay, negative 5 times 1 is going to give me a negative 5. And then negative 5 times a negative 8x. Now again, I have a negative times a negative, right? So that's going to give me a positive 40x. And that's going to be less than or equal to 155. Okay, my variable's over here, and I'm just going to leave it on the right side. And I'm going to get it by itself by adding 5 to both sides. Okay, so to undo negative 5, I have to add 5 to both sides. Okay, so on the right, I'm left with 40x. And then on the left, I have 155 plus 5, which is going to give me 160. Okay. Now my last step is I'm going to divide both sides by 40. Okay, divide by 40 and divide by 40. And what I'm left with, and I'm just going to write that in this space is x on my right, and that's less than or equal to 160 divided by 40. Now I know that 4 goes into 16 four times, so 40 should go into 160 four times as well. But let's just verify that by recalling our old methods. Okay, so yeah, we see that this turns out to be 4 because 4 times 4 gives me 4 times 40 is going to be 160. So that works out. And my solution is 4. So 4 is greater than or equal to x. No remainder here.